Hi guys, today we're going to solve this problem that is a LeetCode 206 problem, and this problem is basically we have to reverse a linked list. So what is a linked list? A linked list is a list type of data structure where you have a node and that node is linked to another node, and same for the other nodes as well. So let's see what is the question that I'm giving a head of a singly linked list. So singly linked list is a linked list which only has a next pointer, and we can only traverse it in one direction, that is from next to the other nodes. Reverse the linked list. So we have to reverse it. Like for example, you can see that 1, 2, 3 and 4, 5. Then this list is reversed because 4 was earlier pointing on 5, but now 5 is pointing on 4. As you can see, 5 is pointing on 4, 3 is pointing on 4, but now 4 is pointing on 3. So now this is reversed, right? And I think that's a very simple observation that the list is observed, that what this question is asking us to do. Now there are multiple approaches to do this. So the first one will be so the first approach would be to use a array data structure, or some sort of data structure to store the nodes. So let's say we have 1 and then 2 and then 3 and then 4, right? Now I want to reverse it, so I will create a data structure that let it be an array, and I will store all the nodes by traversing on this linked list into my array, and I will store that 1, 2, 3 and 4. Now after storing them, what I will do is I will reverse them, and after reversing them, this is going to be like 4, 3, 2, 1. And when it is reversed, I will create a new linked list. And after creating a new linked list, the new linked list will be like this: 4, 3, 2 and 1. So this is how this question can be solved. This is one of the approaches, and this is the first approach. So for this approach, the time complexity will be linear, and space complexity will also be linear. Why? Because we are using an array to store the nodes. And why it is time and my time complexity is linear? Because we are traversing the list from left to right on each and every element, right? So this is one of the approaches. And now let's see another approach. So another approach is more simple in terms of writing code, because it is a very minimalist approach, and so it is a recursive solution. We will use a divide and conquer strategy in order to achieve this solution. So let's say we have these nodes 1, 2, 3 and 4, right? And now I will say, not this node, I will say that this is a generic system. Yeah, let's say we have I, then we have j, then we have k, and then we have n. And I will say that from I, that I want to, that my faith is, because in recursion, especially when we are dealing with recursive solutions, we have this faith and return system. So my faith is that if I call my recursive function on this number, that is from jth head pointer node, then this list should be reversed, and after reversing it, I should get the head pointer of the reversed list. That is, now my pointer is pointing on this one, right? This is my faith. And if this is my faith, then I will say that if this is a reversed list, that it's now pointing as n up to k and j. So now I should not be pointing on this list, right? So I should be, if this is the list, then yeah, so this list should also be reversed, and when it is reversed, then they should be linked together, right? This is my main system, and n should be pointing on this one. This is my main system, this is my main recursive crux. I think things will be more clear if I will show you the code, but as of now, let's just say we have this. Let's start with the code only. I think then things will be better. Things will be way better, right? So this is a recursive code, right? So just for a dry run, I will take this example, that is 1, 2, then we have 3, then we have 4. And now my head pointer is initially pointing on this node, right? And yeah, so now I'm recursively calling this node and storing. Basically reverse list is recursively called, and this is the head next function for that. So what I'm doing is I'm passing 2 at this point, and when I've passed 2, then I will be passing 3, then I will be passing 4, and at 4 this is my base case. My base case will ask me that is it true that the head next is null, because now I am on this node, right? And my head is pointing on this node and my node is pointing on this node. Why? Because I say that the head next is null. Yes, so I'll be returned with this node, and now my node is pointing on the last element and my head is pointing on the well, this is like a global head, but in stack frames we are recursively calling our functions. We will be left with, I think, 1 2 3 4, yeah, the fourth call. This is the fourth call, and at this case h is equal to 3, head pointer is pointing at 3 and node pointer is pointing at 4, right? And similarly for, let's say, for third stack frame. So for this stack frame, what we are doing is the head next of next, head next is going to be this item, and this next is pointing on null, right? This next is pointing on null, and now this should be pointing on head. Now this next should be pointing on head, right? And when it is pointing on head, then we will say that the head next is null. So this is the head next, and now we are saying that the head next is pointing on null, and then I will return this node, and now my node is returned. So basically after this recursive call, after this fourth recursive stack frame is done completing its job, this will be my linked list. It's pointing on 3, and 4 is pointing on this list, and this is pointing on null. So this is my representation for the in third stack frame. This will be the linked list. And now what I will do is, so this is node, right? This is my node, and this is my head pointer. But in the previous stack frame, that is the third stack frame, this will be my node and this will be my head pointer. If this is my head pointer and this is my node, then what will be the then actually this is not true. This will be node, yes, and this will be head pointer. So now I will say that the head of next, I mean this link right here should be changed to head. And now which it was earlier pointing to null element, now it's pointing to this one. Because of this line we are changing the we are reversing the element basically, and now this to the head node should be changed to null, right? And then we are returning the node. So now we are returning this node, right? Let's do it again. And now my head pointer is pointing on this element, right? And my so my head pointer is pointing on this element, and the head of next, that is this node, of next, that is this link, should be changed by the head. Now it's pointing on head, and the next should be null, and we are returning the node, that is this one. And when we have returned the node, then the final linked list will look something like this. That 4 is pointed by node, and one more step, when head is pointing on so this null, actually it's done, sorry. And now 4 is pointing on 3, and 3 is pointing on 2, and 2 is going to be point on 1, and 1 is pointing on null. Like if you can closely see, this is now reversed, and head and node is the, because head will be pointing on the head will be pointing on this element, but that doesn't matter because we are returning, sorry for that, we are returning node. So I think it kind of sort it out, because this is like the new head. We can also, like instead of node, you can also say new head, and new head is going to be pointing on 4, and 4 will 3, and 3 to 4. This is now a reversed linked list. So this is one way of doing it by recursion, because by recursion we can easily traverse at the last element of the node, at the last element of the linked list, at the last node, and just like that we are easy to go, right? Because we can fix a node pointer on the last node, and by fixing that node pointer we are good to go, because that is the new head. And then add backtrack. So first thing is we will recursively traverse the linked list and fix the new head which we want to return. And second step would be to, on backtracking, while backtracking, we will change the head pointers, that is reverse them. And third part will be that now we need to return the new head, right? So if we want to analyze this one, then the analysis would be the time complexity for this solution is going to be somewhere around linear time. I think not somewhere around, it's exactly linear time. And space complexity will be n as well. Now why we have this space complexity as n? Because in stack frame, or the function stack in build stack or heap memory, will utilize n stack frames, that is the number of nodes in the linked list. That is why it's n space complexity and n time complexity. Now let's see the iterative one. So for iterative one, before jumping on to the solution, I will like to point out few of the things. So let's say you have this linked list, right? Now you are at this let's say you are at this linked list. Now obviously the next is pointing on this one, and the previous, and it's pointing on this one, right? Now what I want you to observe is that if we are pointing on this node, then we need to change the next pointer to the previous one. So we need a pointer in order to store a reference of the previous node, let's say a previous pointer. Now after changing it, we cannot go to the next element, right? But so which means that before changing this link, what we need to do is we need to set a current pointer, that we can have a reference for our future iteration, for the next iteration, and this will be head pointer. So basically we will need 3 variables to do that. So these 3 variables will be previous, current, and head. So if I have previous, current, and head, and initially they are all initialized with 0. Now let's take an example test case. So I have 1 which is pointing on 2, and 2 is pointing on 3, and 3 is pointing on 4, right? Head is here initially, and current and previous are null. Now current is equal to head next. Okay, so now current is pointing at this place, which I told you earlier, that we need a current pointer in order to store the reference of the node that we are going to use for future iteration or the upcoming iteration. That is why we need a current pointer. First step for future iteration. Then second step is head next should be previous. Now in this case we will reverse the node. So head next, which is this link, should now be pointing on the previous, and previous was null. So this is going to point on null, right? And then previous, obviously we need previous to be incremented so that we can use it for our future, for the next iteration. So now previous is going to point on this element, and head is going to point on the current element. Why on the element that is pointed by the current pointer? Why? Because we are deciding, or we are declaring that now this node is done with its processing. Now we need to process the new node. So that is why we are moving our head pointer. And when our head pointer is moved, first of all we need to assure that we have a node in our lineup so that we can process it. So we'll move our current pointer, then second part will be to reverse it, and then we will reverse the pointer, and it is now going to point on the previous pointer. Now previous job is done. Now we can move the previous pointer to this node, and now we are done with reversing. Now we can just move the head pointer, which means that now we are going to process the new node. And when we are head pointer, again we will be pointing this with current, and the next link of the head pointer is going to be the previous one, right, in this fashion. And the previous will be incremented because previous job is done, and now head is also incremented because we still have some elements left to reverse. And then I'm going to increment my current pointer to null, right, and then I'm going to change the link of this pointer to this part, and head pointer is also incremented, and previous pointer is also at this place, is also incremented to the next part. Now when we are returning the linked list, we will be returning our previous pointer. If you can see that previous pointer points on the element, points on the last element of the linked list, although now it has become the first element of the linked list after reversing it. So that is like the main crux. Now if you will observe, we only need 3 variables, and to be more accurate, we only need 2 variables in order to just for the auxiliary space. So time complexity for this solution will be linear. Why? Because we are still traversing the linked list, right? And space complexity for this solution will be constant. Why? Because we are using only 2 variables, and we are not using any array, we are not using recursion, we are just using a simple while loop and 2 variables, which is why this is a constant space and linear time. And this is, I think, the most optimized approach. So yeah, if you want to try your problem yourself, then you can have the link in the description, or you can also check the source code given below. Thanks guys, have a good day.